This is the conceptual / ratio type of question, which will also be on your test. In this case, you are figuring out how the electric force between two charges will change from its original value if. And then there is a scenario each time. We have 5 different scenarios here where they tell you that something changes about the charge or the distance or both or all 3 things at the same time, and you're figuring out, well, what is going to be the new value of electric force. So we have, to begin with, electric force of 36 newtons that exists between two charges, Q1 and Q2, that are a certain distance r apart. And then what we see is there are some changes. So the way to solve this is use the formula for electric force, basic formula for electric force, that is, you have Kc, and then you have Q1, Q2, and just to save us time, I mean the absolute value, but in this case, we're just pretending they're positive, and over r squared. How do you figure out the change? Well, to figure out the change, what I'm going to do, I'm going to change the color, and I'm going to put asterisk right here, or apostrophe rather, and then I'm going to add the changes. So in question 1, we know that one of our charges changed. It tripled, so I'm going to put 3 right here. And they also say that the distance is tripled, so I'm going to put 3 right here. Now, the very important thing is you have to realize that r is squared. So in this case, if we tripled the distance, it's 3r squared. 3 is squared just like r is. Then everything else is the same. I'm just going to look at my pink numbers. I have 3 over 9. And everything else is in black, the original Kc Q1 Q2 over r squared, which tells me that it's the 1/3. When I deal with 3 over 9, it's 1/3 over the original Fe. So Fe, the new Fe right here, this tells us it's a new one, is going to be 1/3 of what it was. So 1/3 of 36, that's 12 newtons. That's our new force after the change. The second example, again, I'm going to just, to save us time, I'm going to copy this and drag it. The beauty of doing it electronically, you would rewrite it. So here we go. And I'm going to, just to create some variety, use a different color. So one charge is 1/2. So it's going to be 1/2. I'm going to write it like that, meaning that that 2 is going to go downstairs eventually. And then the distance is doubled. Again, 2 will be squared. Not just r, but 2 as well. So then I have 1 over 2 came downstairs, and 2 squared gave me a 4. Everything else is the original force, Kc Q1 Q2 over r squared. That tells me that my new force is going to be 1/8 of the original. Oops, I forgot the apostrophe right here, boom, of original Fe. So then to figure out the value, it's just going to be 36 over 8. So that's like 32 over 8, which is 4. And 4 over 8 is 0.5, so 4.5 newtons. That's the new force. Continuing with what we have been doing, again, I'm going to duplicate this, change the color for variety. Let's go. So we know that one charge doubles, the other charge doubles, distance doubles, everything doubles. Now the interesting part is that now I have 4 upstairs and 4 downstairs. If I double everything, nothing will change. It's still F original. So therefore it is still 36 newtons. Question 4. Drag it down again. Let's see what changes this time. Let it be purple. 4. 1 charge is quadruple. 1/2. And then 1/2. Now this is tricky, but you can do it. So I'm going to look just at my numbers. 4, 1/2. So I'm going to put 2 down here. This 2 right here is squared and it goes upstairs, so it's going to be 4 up here. So that gives me 8 over 2. Sorry, not 8. 16. I'm thinking of the answer already. 16 over 2, so it's going to be 8 times, and I'm breaking math here, Fe, Fe, Fe. So that's 8 times 36, which is 240 plus 48, so 288 newtons. Newtons. And the very last one, again, let's grab it here. Light blue is a good one. So let's see what the changes are in the last one. So 1 charge doubled, 1 quartered, and distance doubled. So 2 upstairs, 4, this 4 went down, so it's going to be 4 from the upstairs, and then 2 squared, another 4. So that's going to be 2 over 16, which, oops, not 18, 16. La 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 la. Again, our Fe, Fe, which will give us 36 over 8. So 1/8. And we've done that before. That's going to be 4.5 newtons is our new force. So that's how you do these. You just work with your fractions. If you need to review these, go for it. More practice makes